Let us answer this question together. Which of the following is most challenging in auditing deep learning systems? We're looking for the most challenging when it comes to auditing deep learning systems. Option A, we have lack of transparency. Option B, insufficient training data. Option C, hardware limitations. And option D, poor documentation. So please pause the video and select your answer. The correct answer is lack of transparency. But before we get there, let us look at the other options. So for option B, we had insufficient training data. This is important, but this is secondary. Data gaps cause errors, but transparency has a bigger issue. Option C, hardware limitations. This is technical, not audit. Hardware slows down training, but doesn't affect auditability. Option D, poor documentation. This is a challenge, but it is not core. Docs help, but don't solve black box opacity. That leaves us with option A, lack of transparency. And this is the hardest challenge. I once audited a neural net where even developers couldn't explain decisions. So here's a tip for you. Use explainability tools. I once applied different values to show executives why AI denied certain transactions. Which of the following best validates fairness in machine learning models? We're trying to look for what best validates fairness when it comes to machine learning models. Option 1, we have cross-validation. Option 2, bias testing. Option 3, regression analysis. Option D, penetration testing. Please pause the video and select your answer. The correct answer is bias testing. But let us look at the other options to see why they are not right. For option A, cross-validation. This validates accuracy, but not fairness. There's a time I saw models pass accuracy tests, but still discriminate against certain groups. When we go to option C, the answer was regression analysis. So this is statistical and is not fair. Regression explains relationships, but doesn't prove fairness. Option D, penetration testing. This is we're looking at security and not fairness. Pen tests found vulnerabilities but doesn't address fairness issues. So that leaves us with option B, bias testing, which directly checks for fairness. In one project, fairness testing revealed hidden bias in credit scoring. So here's a tip for you. Include fairness metrics in AI audits. I have used fairness dashboards to convince management of bias risks. Which of the following is a primary focus of AI auditing? We're looking for the primary focus when it comes to AI auditing. Option 1, we have model bias. Option 2, network latency. Option 3, hardware compatibility. And option 4, encryption standards. Please pause the video and select your answer. The correct answer is model bias. But before we explain why, let us look at the other options. So for option B, we have network latency. This is a performance issue, not audit. I have been in a situation where I saw latency affect user experience, but it wasn't an audit concern. So B cannot be the correct answer. So C, hardware compatibility. This is technical, not audit. I've been in a situation where compatibility mattered for deployment, but not for fairness or compliance. So C cannot be the correct answer. So we have D, encryption standards. This is security, not bias. Encryption protects data, but doesn't address discriminatory outcomes. So with this, D can also not be the answer. So that leaves us with A, model bias. This is a core risk in AI. In one audit, biased loan approval models led to regulatory issues. Here's a tip for you. Always test AI models for bias. I once flagged bias in a recruitment AI that rejected qualified candidates unfairly. The AI auto-rejected the candidates from a particular gender more than the other genders.